Hey guys, Mr. Isley here. So we're on to lesson number 12 in chapter 5. And lesson number 12 is all about multiplying a binomial times another binomial. So a two-term polynomial times another two-term polynomial. And in order to do that, we use what's called the FOIL method, right? So this FOIL method right here is what we're going to use. And the FOIL method is an acronym. The FOIL stands for what order we multiply things in. So the first one we do is our first terms. We're going to multiply the first term of each binomial times the first term of the other binomial. After that, we'll move on to the outer terms. So this would be the first term of the first binomial and the second term of the second binomial. They're going to be on the outsides of the expression. Then we have the inner terms here. Those are the two in the middle. So they are going to be the second term of the first binomial and the first term of the second binomial. And then our last one is the last term, right? Or last term. So this is the second term of each binomial being multiplied together. After we've done that, we're going to show you how to create a nice little easy stacking method where you'll be able to combine like terms, because that is the next step. All right, and then we always want to make sure that we write it in standard form. Right, and just a reminder that standard form is just another way of saying descending exponent order. So what we're talking about here is descending exponent order. Now the great thing is if our binomials that we're multiplying are already in descending exponent order, then that means when we simplify down, it should already end up in descending exponent order. So it should be pretty easy as long as those are in line. But we always want to check and make sure. So let's take a look at example A here. Example A says x plus 2 times x plus 5. So a two-term polynomial times a two-term polynomial. Binomial times binomial. So in order to solve this or simplify it down, we're going to use the FOIL method. So the first thing we do on the FOIL method is we multiply the first term times the first term of the other binomial. So that is the f right there, x times x. Now remember, when you do this, you would multiply the coefficients first, which there's not any listed, which really means it's 1 times 1, which is just 1. And we don't have to list the 1, but if you wanted to, you could. But remember, we're using the product of powers rule on this one. So when we multiply x times x, we've got to add the exponents, which are 1 and 1. So that becomes 2. So we end up with x squared. Then we move on to the outer terms. So this is the first term of the binomial times the second term of the second binomial. So x times 5. That is what we're talking about for the outer. So x times 5 is just 5x, and it's positive, so I'm going to put plus 5x. Now once I've done the f and the o, now I should be able to go into stacking method. And again, if both of these are in descending exponent order, which they are, the stack is really easy. We just start 1 over, right? And that's where our I result is going to be, and then the L will be here as well, and you'll see that here in a second. So then we do the inner terms, which is the second term of the first binomial times the first term of the second binomial, so that's our I right there. And 2 times x is positive 2x. And we can see these terms are the exact same. They're both x's, all right, with an exponent of 1, so they're like terms. Then our last step is to do the last terms, all right? So the 2 here and the 5 here, the last term of each, so 2 times positive 5, that is our L, right? And 2 times 5 is positive 10. Now with the stacking method, then we can just draw a little line right here and we add down the columns. Well, nothing to combine x squared with, so we bring that down. So x squared. 5x plus 2x is 7x, so plus 7x. And nothing to add the 10 with, so we bring that down as well. So plus 10. Now again, we always want to make sure it's in descending exponent order, also known as standard form. So x squared plus 7x plus 10 2, 1, constant at the end, which is where it should always be, as we've talked about. So that would be simplified all the way down. Now again, just a reminder, if your binomials that you are multiplying are both in descending exponent order, like both of these are, you should always end in descending exponent order. You also should always be able to do the stacking method where it lines up perfectly like this. If one or both of your binomials are not in the standard form or descending exponent order, you got to be very careful to make sure you line up your like terms during your multiplication of stacking. All right, so let's take a look at example B then. So we've got the binomial of x plus 3 times the binomial of x minus 4. So we're going to use the FOIL method because it's binomials. So we're going to do first term times first term. So x times x, that's our f. And x times x, coefficients of 1, so 1 and 1. So 1 times 1 is 1, and x times x, remember, that's that product of powers rule, so we're going to add these exponents. So that's going to become x squared. Then we're going to do the outer term, so x times negative 4, because we include the signs in front. So x times negative 4 is negative 4x. Then we go on to the inner terms. So the 3 times the x, so 3 times x, that is positive 3x, right? And it's important to include signs, positive 3 times x. Then the last term, so positive 3 times negative 4. Positive 3 times negative 4 is negative 12. And so again, we see that in our stack here, our like terms liked up. The ones that were not like don't have anything lined up with them. So draw our line and go down the columns. So x squared, nothing to combine with, so bring it down. Negative 4x and positive 3x, as we've been talking about when we combine like terms, we do it with the coefficients. So negative 4 and positive 3 makes negative 1, right? And then they are x types of terms. So I could either write negative 1x or just negative x. Either one would be fine. And then nothing to combine the negative 12 with, so I'm going to bring that down exactly as it is. Now I noticed when I was multiplying that both of the binomials were in descending exponent order, so this should be in descending exponent order, but let's just make sure. Exponent of 2, exponent of 1, constant at the end, so that is the final answer. All right, well, let me move my paper up just a little bit for example C and example D, and then I would encourage you to try this one on your own. So example C, again, using the FOIL method because we have two binomials being multiplied. So we're going to start with the first term, 2x times x. Now this one's a little different because one of them has a coefficient listed. Now remember, both of them actually have a coefficient whether they have it listed or not, because variables always have coefficients in front. This one has a listed coefficient of 2. This one does not have one listed, so that means its coefficient is 1. So start with multiplying the numbers. 2 times 1 is 2. And then x times x, again, add those exponents of 1 here. And 1 plus 1 is 2, so 2x squared is the first term. Then we do the outer term, so 2x times positive 5. Well, 2 times positive 5 is positive 10. No x to combine with, so bring that down, so that makes that positive 10x. Then inner terms, so negative 3 times x. Well, negative 3 times x is negative 3x. And then last terms, negative 3 times positive 5, that is negative 15. Now again, when I was doing this, I had already noticed that both the binomials were in standard form, which I would say 95% of them that you get are going to be in that standard form, also known as descending exponent order. So when we stacked, I knew that I could just move one over and I was going to be able to line up like terms. So once I've done that, then I can do my combination down the columns. So 2x squared, nothing to combine it with, so bring it down. Positive 10x and negative 3x makes positive 7x. And negative 15, nothing to combine that with, so bring that down as well. Again, because these were both in standard form, this should be in standard form, which it is, also known as descending exponent order, so that is our final answer. All right, well, I'd encourage you to try example D on your own, then check your answer with mine. All right, we've got two binomials being multiplied times each other, so that means FOIL method. So first term times first term, 2 times 3 is 6. X times x, add the exponents of 1. 1 plus 1 is 2, so x squared. Outer terms, 2x times negative 5. Well, 2 times negative 5 is negative 10. Bring the x down because there's no x to multiply it with. Inner terms, positive 1 times 3x is positive 3x. And then last terms, positive 1 times negative 5 is negative 5. Now again, add the terms down the columns. So 6x squared, nothing to combine that with. Negative 10x plus 3x is negative 7x. And nothing to combine negative 5 with, so bring it down as well. Now again, I noticed both of my binomials were already in descending exponent order, so this one should be as well, which it is. So that means 6x squared minus 7x minus 5 is my final answer. All right, well, that's how we do the FOIL method. If you have additional questions, please feel free to reach out. Again, remember your product of powers rule that says when you have the same base being multiplied that you add the exponents. Don't forget that you multiply the coefficients as you normally would, right? And when using the stacking method, make sure that your binomials are in descending exponent order to begin with, which means that we will line up perfectly when we combine our like terms.